Hello, hello, and welcome, either now or in the future. Um, so yeah, after some work on the 500 sub celebration video series here, uh, I think I'm back at it in terms of working on the engine here. There's a lot of different stuff that needs to be done, so yeah, I'm just gonna spend this episode like messing around with different stuff. It won't be very high paced, and yeah, I'll basically just hang out with you guys and yeah, optimize a bit on some of the systems. Let's see. So I remember thinking um, that for this one, this party here is somewhat um, unnecessary, I guess. Because there's no reason to check once again. I mean, this is somewhat wasteful doing this 2 times, so maybe we should just swap and do an else here. I mean, this is basically just storing stuff on this stack and checking it again. So if it's 0, we get ready to pop resources. Um, and if it's not 0, we will set our indices list here. Index to res index, right? So yeah, the first time we will get the one with resource index 0. If it's 0, we will pop it. Otherwise, we'll add it to the list of indices and increase our index counter here. So if this is 0, we pop it and don't do anything. Then for the next one, if that's not 0, well, then we add it to our index list, and so forth. Every time it's not 0, it gets added. Let's see. Yeah, we could do this. We could also save a few potential cycles and just copy this and leave the old values garbage as garbage values. Maybe mem clear these values in debug mode. And we have this in Maybe we want to check index instead. Yeah, that's potentially better. It'll work the same way. I just think that things are still hot in cache, and it'll probably work a bit better. Okay, this is really slow. While we're waiting, I'm just gonna move these menus here around. I guess I should have sped it up a bit. Almost there. A lot of resources. Okay. And it was just a small fix, I guess. If we're branching, we might as well just branch, if you know what I mean. Yeah, so things seem to be working. And if we increase the building extraction speed just temporarily. Let's close some of this stuff here. Oh, it's in the application. Building data store here. Extractor, let's do 1000 per tick per resource. I just want to test whether uh, oh, we don't have, oh, we do coordinate 5 and 3 and 5, 4. This must be it, right? It's the most. Yeah. Yeah, it still works, so. We didn't break anything. That's pretty good. Okay. So that's a small adjustment of that. So we got lots of work to do, but it's not very interesting. So we need to implement some post effects controls in the UI. We want to do instance rendering. I need to mess around with the line debugging stuff in order to create a grid. I mean, implementing a bit of debugging is probably fine. Um, yeah. And in our application, we could do some kind of like menu. If we click on this object here, we would get the information about it. How much iron it stores, for instance. Yeah. Anyway. I think that I need to do all of the boring work in order to make things easier down the road. So maybe we should, what's most important right now? Instance rendering is then optimization. Tile system, we need a chunk system, which is pretty important. Chunk system. That's pretty important. That's pretty important. Um, yeah, so I think multi-mesh support is pretty interesting. I also thought about a PBR rendering pipeline, or her renderer. This section here is getting too small for all of the stuff I want to do. The bug fixes is part of the renderer, so don't need to expand that. Okay, maybe PBR rendering, and maybe a C prepass. Okay, let's order it so that we can do something like optimizations over here. Okay. And let's do features over here. So that's resize support. And let's iterations, iterative workflow. We will always prioritize iterative workflow, since it will make us able to do different tasks way better. So this is features, this is optimizations, this is bug fixes, small minor improvements, this is what improves our iterative workflow. Yeah. Okay, whatever. Yeah, that's a bug fix. Okay, so let me just start by creating different pipelines here. Okay, so what we need to do is, or rather workflows and different optimizations. So in our renderer front end here, we want to be able to ask our front end to upload some stuff. Yeah, we return this instead. Returns an index and half widths from AABB. Snapped two vertices. Create custom textures. Yeah. Let's get rid of that. This is not needed. Since we're doing const here, we can pass in temporaries as well. Right now, we do draw primitives. Yeah, okay. So I'll do the update data thing. Create custom texture, temporary methods. Let's see. It's actually part of the, let's see, draw calls, initialization and destruction. Yeah, we have this extern, right? Yeah. All right. Temporary. Also, I want actually to couple the ImGUI layer and the renderer backend, probably the renderer, um, because I've noticed that some of these function calls here, I mean, obviously we do some new frame stuff that might still be relevant to do out here, but whenever, okay, let's scope this. Let's see. Simulation and hi there. Thank you very much, buddy, and you too. Always nice hearing from you. How are you doing? Okay, because this is a problem here. I mean, the end thing here is what actually kind of like tells ImGUI to render. And that means that whatever ImGUI data we have submitted is actually actually getting sent or packaged, I should say, to our draw calls. But if we do this before all of these calls here, we will get our profiler timings for the previous frame, which is all right, but that means that we actually have something like in this debug stat window here, all of this stuff here until we reach the application tick is actually for our last frame, and this is for our current frame, which means that obviously it ends up looking a bit weird and the totals do not make any sense, so maybe it should be moved into the draw call here instead. Like we could actually perhaps do it even right before the GUI pass, and then only our call it, end frame and execute percent would be what we really can't, what do you call it, profile. So this would be the only, these two would be the only two methods that are from our previous frame, which I think is all right. Also, it would kind of like move these calls out of here and make it a bit more organized, I guess. Does our render actually know about our GUI? I think it does, right? No, it knows about ImGUI, so that's all we need actually, since this call here is just ImGUI render. Yeah. And our profiler is referenced, right? Yeah, it's referenced. Okay, let's just move it then. Let's see. So, in our backend here, GUI.header end. Yeah. So this should reorder some stuff. It had deleted a lot of stuff, right? Let's see. Well, okay, didn't work out as I expected. I mean, this should be scope timed. Well, these function calls should return. And for some reason, the GUI pass here, well, it's after. Okay, if I move it up here, yeah, there's some bad interaction going on, I guess. Okay, I'll have to fix that later on. It's not very important. Yeah, I think I'll redo some of it. I think I'll redo some of it. Yeah, maybe there's a call I'm missing somewhere. Anyway. The cubes. Oh, that's the AABBs. Anyway, where was I? I was messing around with the front end. So render a front end. Let's see. So I wanted something like update Thank you very much, man. Hope you're having a great day as well. Um, all right. So I want something like update this value, update this information, set this stuff passed from a ImGUI layer. So in our function here, all of these side panels here should be able to adjust our information. Right now we're setting stuff that's stored in a upload heap based constant buffer. And we actually want our post-processing stuff to be organized in a default heap constant buffer instead. So if we look at our shaders, we have our emissive pipeline, I think. Yeah, where we can adjust the emissiveness of something that is rendered with emission. For instance, this is rendered with emission. I adjusted the emissiveness quite a bit down. And if we increase this, it already glows a lot more. Yeah, so this is one value. The material should hold a emissive factor, I guess. We could do that. We could do that. So when we do emissive calls, not this should be collapsed. So in draw calls, when we do our emissive render pass emission here, we do bind the constant buffer and we have a pipeline polygon pair. So I'm thinking this could be stored in a material. So our materials here have such a nice alignment. I really don't like messing with it. Renderable mesh. Do we even use that one? Drawable mesh, that's old stuff, isn't it? That's pretty old stuff, I think. Our transform is not old. But I think this is old stuff. Let's see. Do I get away with commenting out that section? Yeah, I don't have any problems, it seems. Nothing actually referenced it, so away we go. Transform matrix, do we even use that one? I don't think so. I don't think so. Nope. Yeah, so I really don't want to change our material loadout, but I also want this emissive factor here to be something that we can parameterize. I guess we could do packets of extra data here. So if we draw data here, it's also aligned pretty nicely for 32-bit integers. We have a lot of information. We have our mesh index, we have our material index, we have our texture index, we have draw flags. Our transform data though. This is 3, 6, 10. So we actually have like 2 more slots of 32 bits. So we could store it in transform data. We could store it there. So yeah, feature. Let's try setting this and then maybe setting this even lower. Why did we mess up? Resource manager. Oh, that's an old class. We don't even use the resource manager anymore. I totally forgot we had one. Oh my god, that's a long time ago. And this class did anything. Okay. Sometimes you just find old code somewhere lying around doing nothing until you run into trouble when you remove its dependencies. Resource manager. Oh my god. This is some old stuff. It's all commented out uh, since we actually ported all of the code. Okay. Okay. We might find use for that class eventually. Yeah. I'm definitely not buying it. So, our pass data. What's stored in our pass data? Mesh creation data. Okay. Resource types. This is for all of our rendering pipeline stuff. So our pass data, is that solely on our backend here? Resource type, draw types, rendering types. No. No. Rendering types, is that, where's that stored? Pass data, okay. Like directional, oh, it's all aligned. It's all aligned. And that's pretty annoying. That's pretty annoying. And I guess we don't want to store it somewhere. I mean, we would probably end up breaking this anyway. This is on the upload heap. Accessing it on the upload heap is somewhat annoying. And I mean, you should be able to select a material somewhere outside of this and basically just set a value. Maybe we want a different material buffer for custom material data. Not called material, but maybe special instructions or something. Because this emissive factor here is nice to control. from somewhere. And when we submit it for rendering in our application, yeah, when we submitted buildings, and we simply pass along our special flags. Building draw params here. 1, 2, 3, 4, 5, 6, 7. Yeah, this is not aligned anyway. And these could be removed, split into something else. I guess these building draw params here could store some data, but I mean, shouldn't you be able to edit a material and set the emissive factor? And then the bloom brightness threshold itself is something that should get adjusted. Yeah. Yeah. I think it should be part of the material stuff. Also, because we access the texture index, we might as well access the material. Okay. So we will handle this one. Yeah. We'll do it. We'll put it on the material. Yeah. And let's step through it then, our application. So whenever we create a material, which we do up here, on materials, solar panel, let's see our tower here, temp material, emissiveness, let's do 5 for instance. And we use a core. So when we pass a material, we pass another material, and we simply write our material properties. I think this should change to just material. Let's ditch just material properties because it doesn't make sense to have a separate struct for that. Let's look it up and let's remove it. Yeah, this is more like actually back-end stuff, which the front end doesn't need to care about. Okay. So in our pixel shader here, let's do the what do you call it, material array. Also, let's grab the material, load emissiveness, or rather yeah, okay. And it shouldn't break yet, although we should pad this if we're to use any other variables. Okay. Materials, constant buffer object, mat index dot emissiveness. Let's see. Do we run and compile? We do. And our heat tower here has a emissiveness of something. But let's try changing it rather. So we swap back to emissiveness of 1. Yeah, and then immediately we lose our emissiveness. Whoops. And let's look at this pixel shader stuff here. Oh, that's not it. This one. So maybe we just want maybe we don't want to actually multiply the vector here, but instead we want to multiply by this. And then we should find some kind of like structure for that. So let's see. In emissive shader, we have this rather thingy. Thingy. Okay. And that's just to remember that we actually want to do something about that one. So, okay. We can now control our emissiveness from our texture here. Let's see if we do 2 times but 3 times. And then 4 times perhaps. Hello, man. I'm pretty great. How about you? And yeah, definitely, it's been a long time. Yeah, so we actually want the shader to output a more intense color to our emissiveness texture. Let's do float emission. Oh, I'm happy to hear, man. What's your current project? Yeah, so now we end up getting something very bright, which we like. So not only do we surpass the threshold, but we do actually get a more intense bloom effect. Yeah, so this is not doing anything. This is definitely doing something. I don't know. I don't think it's that difficult, but I guess I'm biased. I've been using it for quite some time, so mostly I understand it. I think it's probably the same as Vulkan, maybe for some a bit easier. Oh yeah, I remember. I used to do a bit of JavaScript back in my early days, teens. Uh, the JS struggle is real. Right. So anyway, we can control our emissiveness from our materials now, which is fine. That's one small tiny upgrade that I wanted to do. And we got rid of some old data structures that we don't use. So the house cleaning has begun. All of this stuff here. Yeah, I think it's fine. I actually think we use it right. Uh, yeah, we grab it from the frame data. Do we actually store it anywhere? Or we just... What happens if I actually frame transient data? Is that what we pass? Yeah, we do. Okay, so we're passing this struct around, so no reason to remove it. Passing it around like delicious drink. Okay. So that was one shader, and we still need to figure out how to update this from our GUI, because we want to be able to adjust the bloom brightness threshold from outside our shaders. So that's the emissive one. The line shader doesn't do anything but draw the actual lines, so we don't care about that. Our Is this the debug one? No, this is our regular polygon shaded sh pipeline with our shadow map stuff. So that's not going to need any adjustments right now because we already control most of the data one way or the other. So we have our bloom here. Oh yeah, so definitely these weights here should be controllable, I guess. Uh, yeah, I think so. I guess we could create a more dynamic bloom shader here. This is a hassle to implement adjustable. Do you think so? It kills your brain cells. I think I prefer the bloom is not controllable per se right now. But I guess you could kind of break it down. In this shader here, this one, it tells the pixel shader which render target to target. So you can have multiple render targets. For instance, in the tutorial I just did here on the channel, if you open the deferred renderer here, you'll see that it outputs a PS output struct, and inside that struct there are 1, 2, 3 render targets. So you can like index them if you have bound several ones. But this only has one render target, so therefore it's just a SV target. So the vertex shaders are the geometry shaders, or all the shaders before the rasterization layer actually output something called SV position, which is the position in normalized device coordinates of whatever pixel, or rather not a vertex or interpolated vertex. Yeah, it's the semantic in HLSL that just tells us that we're outputting to a render target here. Yeah, so this explanation as well says that you can have up to 8 render targets that you can write to. Since we're only doing one, we're returning a float 4. I hope that makes sense. But yeah, you could, for instance, have a pixel shader that, well, it's because in GLSL, especially OpenGL, you would do something like, I don't know what the call is, can't remember, but it's something like set render buffer or draw buffer or bind. Yeah. Uh, yeah. So you basically do it outside of the shader for OpenGL, and then inside the shader you can actually through a value kind of like target the output, but it's done differently in HLSL. Yeah, exactly. But also you do the same thing in DirectX, although. So if I show you my pixel shader here for our polygon rendering, I have 2 outputs. I have the color of whatever pixel I'm trying to draw and the brightness value of whatever pixel I'm trying to draw. and it simply checks if a pixel is so bright that it should be stored in a separate render target, which um, kind of like, stores a brightness value. So let me show you how it looks in RenderDoc. Oh, this is the other project. Let me find the project here. So, for instance, let's find the polygon draw call. I can't zoom here. So this is a draw call, I think. Let's see, texture viewer. Yeah, this is our render target. So you might see that I draw different stuff here. Then we draw, maybe it's not light enough, but we draw several objects. But over here you can see we actually draw two objects, two textures. Right now one is totally black, one is our actual output. So let's see, do we end up with something that actually gets drawn into this buffer? No. No pixel is so bright that we actually draw something onto it, but then we swap pipeline to something that is called a emissive pipeline here that draws. Let's see. Oh, it's because I haven't built anything. Whoops, my bad. Of course, if I build some buildings, it might look different. Okay, let's capture this frame instead. Okay, we'll redo it. So if I draw our objects here to our regular buffer, you'll see that we draw our tile map stuff. And then I draw the buildings here. Nothing happens in terms of our emissive texture. I'll keep on drawing, and then I'll swap to the emissive pipeline, and then I should be drawing. Yeah. Immediately you see that we draw the emissive part of these heat towers here. Can I increase the? Yeah. So in this scene here, this tower here, for instance, has an emissive part that I render to this texture. But maybe if I had a lot of lights in the scene that made things glow. So let me just show you how it would work. So if we increase our light intensity for the whole scene to a maximum here, and let's try to capture that frame. Whenever we do our draw call here, we still draw into the two separate buffers, but you immediately see we actually do have a bit of super bright pixels on the spacesuit here. Let's see, do we end up with any more pixels being bright? No, it doesn't really seem like it. So only the spacesuit is kind of like shiny enough to actually emit any light naturally when we increase our scene light. I don't know actually if you can see a bit of a bloom effect then. Uh, if we increase the lights, let's try. Let's see. So if we increase this, I guess it gets a bit more blurry up here. Yeah, it seems a bit more blurry, so I think it would be emitting a bit of light. It's not very intense, and I don't think it's supposed to. Um, but yeah, so that's basically several render targets. Yeah, the bloom shader itself. No problem, no problem. Feel free to ask anytime. I'm just hanging out and doing somewhat boring stuff on the engine anyway, so might as well talk a bit. So yeah, these sampling methods here. Oh, I really want though them to be possible to control outside the renderer. Okay, okay, okay. Let's do it. Bloom pass control values. We need to do that. Then our downsampling method is just, well, downsampling. I guess we could control the downsampling method or the offsets. But I mean, I guess we already do that, but downsampling a texture to half size, well, that's not very interesting actually being able to control. The only effect you could create was skipping pixels or something. Yeah, definitely not gonna implement an interface for that. We might keep do the bloom stuff. Let's see. And this we need to be able to control. So we need our gamma and exposure levels. Okay. And the stencil effects are a reminiscence of the past. Right now we do not use them for anything because my whole heat wave generation stuff was not very successful. Our shadow mapping here works by already by controlling an interface, transparent polygons. Yeah, this is just manual setting of the transparency on whatever we draw with this. I guess we could control it if we really want to, but also this data here is somewhat unnecessary. Transparent. Yeah, basically we could skip all of this. Well, I guess I would find some projects to do and maybe a good book or two on some basic algorithms and simple programming patterns, and then just try to build something. Maybe uh, okay, I did something bad here. Oh, that's the bad thing. But yeah, get some books, do some small projects. Maybe you want to do a program that does some kind of sorting thing or organizing some of your stuff, or maybe you want to try out image processing or whatever. And just build simple projects like that until you feel like you want more of a challenge. Ah, whoops. Okay, there's a bug. Let's fix that bug. I hope that answers your question. There we go. Yeah, definitely. That's a great way to do it. Okay. Yeah. So I want to be able to control these two values at least. Let's see. In our backend, how do we arrange our buffers? I mean, this is somewhat wasteful, isn't it? Also, so let's just go through our pipelines. Our Polygon pipeline here should have constant buffers on the upload heap for our um, uh, render Polygon transform data and stuff like that. So that's fine. It should have render targets. That's not related to constant buffers, so we don't care about that. The shadow map is kind of like borrowing the opaque pipeline constant buffers, so it doesn't have any of its own, so that's also fine. The skybox pipeline. Wow, that is wasteful. Creating a skybox pipeline. Well, do we actually... I think that is pretty wasteful. Upload pass data. The skybox pass data. Uh, yeah, this is just straight up pass data. Well, that is pretty pretty wasteful, I think. Because in our skybox renderer here, and the world position is the input position plus the, and then offset by the camera. So what information do we actually use here? We have our past data, we have our object data. Well, the object data is basically what we're talking about here. Yeah, I don't think this should be it. Yeah, hard-coded skybox data. Yeah, I don't like this at all. At all, at all, at all. Yeah. I mean, we basically store only this in a two constant buffers that are aligned to our 64 kilobytes. And how many bytes is this? It's like maybe it's 72 bytes. So out of 64 kilobytes, because that's the default alignment, we use 76 bytes. That's just like so impressively wasteful, and we have two of those. What's the what's that? I only use two libraries, ImGUI and the Microsoft DDS Loader. But what's the infamous GIM, GLM? Oh, oh, the math library? No, I'm using the standard library, DirectX Math. So I guess you could say that I'm using more than one library if you count the standard library from Microsoft. Okay. If we were to like we could also attach this to the well, with the new Ryzen CPUs, you'll start seeing more AVX 512 instruction sets. It's really, really good at doing those instructions. So maybe we'll see more broadly used. It's not a dumb question, and there's definitely no problem in asking it. Windows Strudel. Well, I just started out by doing DirectX12, so it's my first graphics API. So yeah, that's basically why. Uh, could I do it all over? I think I would have started out by doing OpenGL or DirectX 11. I mean, yeah. Yeah, I guess you could uh, say so. Uh, so we could couple it to the other Polygon pipelines here. Yeah. Sometimes things just end up that way. Yeah, it only runs on Windows and Xbox. But yeah, I'm not trying to be a professional game developer. I'm just doing this for all good. Uh, for some good fun. But also on Xbox. People seem to forget that, but I guess it's because it's not as popular as the PS. Uh, um, okay. I can't really decide on whether to fix this. It's not a problem, but I don't like the way it works. So if I update some frame resources here, yeah, sure. And no offense taken, that's for sure. I don't mind the question. What I mind is people appearing in chat out of nowhere, being like, "Oh, why didn't you do this? That seems like a stupid idea," or uh, like blabbering on about something that they think that is relevant to me at least. But questions are welcome, and sometimes I don't have a better answer than, well, it's just the way it happened to me. Okay, I can't decide on actually fixing this minor improvement here of the buffer usage, so I'll skip that part for now. Let me add it to my board so I don't uh, forget it. So don't use 2 times 64 kilobytes on Skybox data that is 2 times 76 bytes, and then a lot of exclamation marks. I should remember. Fix it. Okay. Are you yourself doing anything graphics related, Strudel? And this should be fine. This pipeline deserves its own buffers. And then we have the emission pipeline, which uses the constant buffers. So I guess, huh. Well, I guess this is actually something that we actually use in different shaders now. And I guess I could follow the argument of actually putting it in the past data buffer. Um, nah. Um, hmm. Also, what can we actually bind to our root signature? Well, I guess we could store it on the past data. What is SAAS? Ah, okay. That seems interesting. How do you like it? Whoops. And what buffer do we use? We use the post per FX parameters buffer. Well, if I ever saw a buffer that is supposed to be with generalized parameters. Huh. Yeah, I kind of like, well, I felt like physics engine programming actually taught me a bit of math that seems to have stuck with me. But yeah, there's a lot of difficult math in game programming. Constant buffer for a distant standard. Uh, And this is not big enough to overflow the 256 byte alignment for a constant buffer. So that would mean that we could actually uh, oh, it's going to be so horribly ugly. But we can actually use this one. Yeah. So instead of doing this, okay, so we do also use this one for the downsampling buffer. And this is way less. I won't actually answer where I'm from because I want to still be somewhat anonymous, but I'm from Scandinavia. You might be able to hear that from my accent. How about you? Uh, let's see the stencil stuff. Yeah, we don't need. We don't create a constant buffer for that. Stenciled merge is fine. And the tone mapping. It uses the. Okay, so we would need to change that one. So let's do post effects. Post effects. Uh, constant buffer layout. Let's see. As of bloom pass data size. What did I say it was? 160. Do I sound more German or Scandinavian? Be honest. I suspect I sound more German. Not that there's anything wrong with that. I love Germans. But and let's see. So let's do meaning 0 to 511. Bloom pass. Yeah, that might be right. Whoops. And then we have a block. Or something like that. downsample data, and then plus 256. But right now I'm listening to Swedish music. Swedish old people music. Oh, thank you very much. I really appreciate it. Hopefully I'll see you around here. Yeah, exactly. Exactly. you, you know it. It's good. And then, well, the tone mapping stuff is not really using anything. I just need to update it. Okay, so this should be our layout, right? And then add uh, combine step. Whoops. Okay. Yeah, so let's just see post effects parameters buffer. That is fine. So we will just use that one. Let's see. Let me copy this. And then maybe the post effects pipelines should have some kind of like uh, maybe even a GPU virtual address for the constant buffer data. Yeah, let's do that. D12, D3D12 GPU virtual address, constant buffer, offset. I think I would store that. So when I do the bloom pass here, let's see, constant buffer pipeline. Yeah, so that means it's bound. Well, I guess you don't need to attach it if you actually use the same buffer for everything. Okay, so let's reshape this part of the code then. Yeah, it can store a constant buffer, but it doesn't need to. Okay, so we start out by creating the PostFX constant buffer here in the Bloom Pass stuff. Then let's not do that. But let's say ppipe here, it's constant buffer offset, and then grab this one, get the virtual address, and this is a virtual address, which is just a UN64. So we can add two times this. Use the PostFX param buffer. Then also for our downsample here. Okay, let's see. Create a small struct for that. Bloom params. Struct. HDR. Final tone map. Settings. And let's do float exposure. And float gamma. And yeah, we would know our kind of like data layout, and this is only for the backend itself. The front end doesn't need to know about it. So let's store this struct here. The downsample data, that's just some offsets, right? Yeah. Downsample to 2x params. And then two buffer slots of Bloom, downsample, one slot, combine step, one slot. Okay. Actually, this is supposed to be the other way around, but I guess we can just create it whatever we like, whatever way we like. Let's just do like this then. This is our layout. Doesn't really matter. Let's see, gamma exposure, or rather HDR tone map. Final tone map settings, that is it. And of course this needs to be wrapped around the constant buffer alignment. Okay. Okay, let's rewrite our stuff then. In the downsample thingy here, we don't actually bind this anymore. We do the p-pipe bloom pass. Where do I actually use this? Do I even use it? I'm not sure. Nope, I don't use it. Yeah, of course. Having fun. Oh, I'm sorry. Shouldn't be singing along here. Okay, yeah, the downsampling stuff is obviously not transferred correctly. This should also fail, right? Okay, let me move it a bit around. One unified buffer on the default heap here. Okay. Universal postfix buffer. Which one is the first one? Let's just do tone map pass through then. Let's see, get virtual address here. Huh? Where am I? Oh. Let's see, Bloom data here. Not a date, Bloom data. Okay. So our Bloom pass here will not use a constant buffer per se. Should we just delete the whole thing in the pipelines here? Yeah, maybe we should. And then instead we'll do the X12 resource, post effects pipeline CBs. Post effects constant buffer. There we go. That's better. Okay, that's more clean. And then we need to upload the Bloom params. Upload Bloom params. Obviously, we fix that later. So this is our constant buffer stuff. This works. And we copy this. We copy this. And we need some downsampling values. Let's see. This is the downsample params here. Downsample params. And this is our downsampling, and this should be yeah. We won't be needing it, but we might as well set it. And let's see, stencil stuff here. We don't use that right now. Do we actually create some buffers for it? I don't think so. No constant buffers at least. We could disable the whole pipeline here. Yeah, maybe we should do that. I also need to clean up the RTV heap for that. Okay, never mind. That will be whenever we update stuff like that. And let's do the constant buffer stuff here. Okay, so um, when we want to upload this stuff here, we don't set an offset because we have this map here. So the first one are the two bloom effect parameters. So our let's see. Memory. And I also want to actually maybe fix this function here. Because it actually kind of like implies that our CPU is going to read write from it. Oh. Yeah, just want our resource here. And it wants to store these two parameters, which is fine. Then we want to upload the let's see, offset. Two times this. So now we did the downsample as the last part, I think, didn't we? Downsampling. Yeah, plus the final tone map. So let's move it just so it makes more sense. Downsample after the. Oh, I haven't actually created the final tone map ramps. So let's do something like flow. Let's see, final tone map settings, settings dot exposure 2.2, or rather that's the gamma, and then settings gamma 2.2, and then we want to queue the stuff here, but our offset is equal to size of, or rather offset times 2. And let's do size of this instead. Okay. Now we actually want to write a whole constant buffer here. Well, oh, no, we don't. Because we don't want to write garbage values. Plus this final tone map size of course. And this should be okay, right? Let's see. Oh, of course we need to fix stuff like that, and then in here constant buffer offset. Let's see how many problems we have. Oh, it needs to be initialized first, of course. So I guess we have to do it up here. Whoops. Okay. And let's see, our bloom effect still works. Seems so. Okay. So basically I've collapsed the post-processing stuff into one constant buffer. And that means that now we can actually thank you for your continuous support, buddy. How are you doing? Then we can do a function here where we do something like void update post effects settings, and maybe we should do something like a void pointer data const unsigned int bytes, and then a pipeline target DX12 backend pipeline post effects add a const type, and it will call our backend. Let's see. Let's see. Did I? Let's see. Potentially temporary control calls void pointer data constant signed int. Whoops. Set post effects data bytes, and then post effects pipeline type, of course, const here. Type. So in order to do that, we actually need to do something like render to texture pass. Let's see this. Do we actually force upload here? Yeah, we do. Okay, let's copy most of this, except we don't need all of it. Okay. We don't need to do draw calls, we don't need to set render targets, but we do want to and let's do let's grab our post effects pipelines here, type here, dot constant buffer. Oh, I can't pass in the virtual address, of course. Can I create a function that kind of like does somewhat the same thing? Okay, wants the resource. Okay, so we need to compute some kind of offset. In bytes, I think. Yeah, we should be able to calculate that, right? So if we do post effects constant buffer, and then this let's do common. I think this should be fine, right? This would update our data, but our offset should be, let's just try test offset was, and then a UN64 offset equals this get virtual address minus the post effects pipeline type, that's CB offset. I think this should be it, right? Okay. And let's do DX12 renderer update. Let's see. What did we actually call it? Set post effects data. Data bytes type. And let's see, renderer controls, blah, blah, blah. Let's do a ImGUI button, bullet button. Do it. Let's do, what did we call the front end call then? Update post effects settings. Let's do final tone map settings, dot exposure 1.5, and then settings gamma 1.5, I guess. Settings address, and then the size of final tone map settings here, and then let's do a post effects gamma bloom tone Reinhardt. Okay, let's test that. Renderer controls, do it. Okay, we're having a lot of errors. Well. Okay, we can't use the virtual address. It definitely doesn't like that. but we could maybe store a byte offset instead. Okay. Okay. Alright, let's fix that then. So this is still fine. All we want to change is actually this. Let's do a size t byte offset. Let's see, byte offset equals this. This is just 0. Downsample combined here. Okay. And post effects. Okay. And of course we don't need this. And we don't have any errors anymore. 512, okay. Oh, whoops. Let's just do the offset here. Okay. We upload our data here. All right, so that should basically be it. We set our post effects data to whatever value. And in our final draw, this one, final, yeah, we bind our constant buffer view here. Let's see, effect data. Let's do float exposure. Is that the one we bind? Let's see, pipeline, root signature. Empty sister textures, blah blah blah. For post effects, first parameter, second parameter, third one, constant buffer view, which is 0 0. So that means it's this one, float, gamma, right? Isn't that the way I mapped it? Exposure gamma, yeah. Okay. Exposure, and let's do gamma here. And let's see. And we immediately are able to change our exposure and gamma levels. Okay, so let's create some verbose controls for that. Let's see. Let's do gamma and exposure. Let's do some spacing as well. ImGUI spacing. There we go. This is the shadow map stuff. Let's do some spacing before that. Okay. Do we want to store this somewhere? I guess we want to store it somewhere, maybe on the renderer front end as a setting. Do I have something like called settings? Or do I just do UI panels? Oh yeah, noise panel settings. Now struct. Tone map settings. Float exposure. Float gamma. Also, let's see what the old values were. 2.2. And this exposure was 0.5. Okay. Maybe 0.5 then. Should this be default? Okay. Tone map settings. And then we on our panels do have the control over our values here. So let's do a if ImGUI slider float exposure and float exposure panels and the minimum exposure should be 0, I guess, and the maximum 2.0. And the format could be something like percent one float. Now let's do something like settings. Also this, I think. Full updates. Nah. I don't think this could be true as at the same time as this one, so let's do and settings gamma. Yeah, we could just do this. Yeah. And let's of course do the exact same thing just for our gamma. Gamma, and this should be 2, or rather 3 maybe. Probably down from up from 1. And let's do gamma here. Gamma. All right. This should give us some controls. Yeah, we have control of our gamma and exposure now. Okay, interesting. Great stuff. So that's what we wanted for this one. Yep. All right. We could still mess around with this. So there's still some work to do, but at least that one is done. And we have the overall interface for it now. So should be no problem actually updating the Bloom stuff and whatever data we want to update now on our postfix pipelines. All right. Well, it was a somewhat slow stream today, but at least we got some work done. I felt like doing a somewhat slow stream, so yeah, I hope you guys didn't mind. Anyway, thanks to everyone who tuned in during the stream or in the future. If you want to support the channel, please consider commenting, liking, or subscribing, or even checking out the description down below. All right, please take care and see you around. Bye bye.